Hello, good morning, everyone. So I will present you xBGP, which is a new way to add programmability and innovation in routing protocols. So this is a joint work with my colleague in UC Louvain, Belgium, but also with Laurent Vadbever and Randy Bush. So the first question we can ask us is why we would like to bring programmability inside BGP. So you might know in modern network, you have routers from different vendors for many reasons. So the first one are for economical and stability reasons. For example, if you have one vendor that have probably a crash or a bug, there is less chances that other vendors have the same problem. And so this is the first problem because all the vendors do not implement the same set of functionalities. And this is really really restrains the network operators about what they can do on their networks. And so, well, operators would like to constantly tune their network for the evolvability of their networks, but they are limited by two main factors. The first one is the network operating system, so the OS of the vendors. You can consider it as the black box, where you have only the interface provided by the vendor, but also by the standards itself, because you cannot do anything with your implementation and your protocols. So BGP are standardized by the IETF, and so this is something which is really constrained. So for example, if I would like to add a simple functionality where I would like to enhance the visibility of the BGP control plane, well, this is really complex. Because if I have an intra-domain routers that would like to prefer, for example, European routes among the other, I have no clues. Yeah, I agree that you can do this with BGP communities, but this is really cumbersome, and this is you have to add a lot of configuration of all your routers of your network, and this is why there are a draft that has been proposed in 2016, where they simply add a new BGP attribute to add the latitude and longitude of the router that receives the route. So the idea is really simple. Each time you receive BGP update from your peers, you add the latitude and longitude of the router who received the update. You spread the information inside the network. And then to avoid pollute the internet with your custom attributes, you remove it on the edge routers of the network. So this is quite easy to understand and to maybe implement, but not at all, because there is a lot of process to achieve this feature inside BGP. So the first one is the standardization step. So in order that all the routers must talk the same language, I would say. And so there are a standardization process by the IETF. And here on the slide, you have the standardization delay of the 40 RFCs related to BGP. And you can see that in median, you have to wait roughly 4 years to have one standard for one feature. But that's not all, because you have also to wait vendors to implement your feature inside the router. And finally, you have to update your routers. But the problem is if you want to add a new functionality as a small network, let's consider Belnet, which is a small research network in Belgium, you cannot easily influence step 1 and step 2, because you maybe some IETF people do not have the same idea as you and do not are not interested by your feature, and also the vendor side is also complex because you can't maybe not have the right license to add to ask for a new functionality inside the network. And finally, yeah, you have to update the routers, but this is something you can fetch from the vendor. Okay, so let us summarize the main problem inside BGP or routing protocol in general. So the first problem is that you have routers from different vendors. Then protocol extensions are not implemented in all routers. And you have also the slow upgrade process as I explained before. And with xBGP, we would like to bring innovation back in programmability inside routing protocols. Okay, so now I will explain the basic of xBGP, and let me just introduce how we can update in a classical way routers. So this is the vendor that must add and implement it inside their routing stack, the new feature. Then they need to compile it and generate an image that the network operator can fetch and update to its network. But during this process, the operators must flash the router and reload the session, and so they will lose all the neighboring session, all the routing peers they have established with other people. And so, yeah, to bypass this classical update, I would say we will leverage eBPF, which is basically two core components. So the first one is eBPF bytecode. So this is a bytecode which is multi-architecture compatible, which is really nice for our use cases because routers have CPUs from different architecture. And then you have a runtime environment that will fetch the bytecode and execute it inside an isolated environment. So you can think about a kind of Java virtual machine. And so with this eBPF technology, what we can do is first, as a router vendor, you have to add it inside your routers. And then if you want to add a new functionality as a network operator, you will simply write your own plugin, xBGP extension, then compile it inside on eBPF, sorry, and then inject it inside the eBPF virtual machine that will interact with the vendors so that they can fetch the right data structure to compute the functionality. And thanks to this method, you don't have to reboot or flash a new image in your router. Okay, so with this view, we would like to shift from another paradigm where now you have something which is more black box, where vendors have the full control on their router, toward something more gray, where you have the BGP code, which is closed source for the vendors, but you can interact with this code with the eBPF virtual machine, and so the network operator have a way to influence its router. Okay, so how we manage to make xBGP compliant and BGP implementation? For that, we rely on the BGP workflow that has been defined in RFC 4271, and this workflow normally is implemented on all BGP implementations. And the BGP workflow is the following. Each time you receive a BGP messages from your peers, they goes to the theoretical edge ribbon. Then you have import filters to apply some policies. You have after all the route will go to the lock rip. Then you have the BGP decision process that will select the best route toward each prefix. Then again export filter. They go to the address route, and finally you announce the best route to your neighbors. Okay. So this is the workflow, but how to access this workflow? Because on traditional implementation of BGP, you have only the interface is provided by the vendor. The famous one are CLI, netconf, or SNMP for monitoring. And with xBGP, we open the lid of BGP, sorry, and we expose this BGP workflow so that the xBGP virtual machine will execute or extend your extension to this BGP workflow. And so, yeah, if I take back my geographical location plugin that I introduced previously, it needs to be executed somewhere. And for that, we introduce insertion points. So those are the green circle here on the figure, where you can execute any code from the operator. And so, yeah, the geographical location extension is divided in subparts, so it must cover the whole BGP workflow. And you have to first decode the geographical location that has been sent from your peers. You have to add it inside the route, use it, delete it, and encode it. And those subparts will go to the right insertion point, and the VM will manage to execute this subpart of the plugin to the right location of the BGP workflow. Okay, so thanks to that, you have to implement once the geographical location extension, then it will be executed on every implementation of BGP, or at least those that are xBGP compatible. And we successfully managed to modify bird and FL routing to add our xBGP layer so that the eBPF virtual machine can execute any plugin that the operator can provide. So you can think as xBGP as a link between the operators and the vendors. So the vendors will provide the OS, so with the routing information table, the peer state, the memory, IO, BGP state, and stuff like that. And the operators will interact with the xBGP layer so that they can interact with those subpart of the network operating system. And so the advantage is that you only implement once your xBGP layer on each BGP implementation, and that's it. You can now execute your plugins, your xBGP extension. So, so this is just for your information. We had to slightly modify FL routing and bird because we do not have all the information to execute our xBGP stuffs. So for your information, we had to modify some line of code inside both FL routing and bird. So this is just some line of code we have had to modify. Of course, we have also implemented other use cases to prove that the solution is really that covers a lot of use cases that the operator might want to add inside their network. So I won't explain them in details in this presentation, but I will just explain one of them, which is the BGP zombies. What is the BGP zombies? So this is simply routes that are no more reachable, but still in the routing table of some part of the routers in the internet. So normally, if you have a prefix P and you would like to advertise to other peers inside the internet, you have to rely on routing protocols, here BGP, to announce your update to the rest of the internet. But for some reason, the prefix P is unreachable anymore, and so the routers that detect it will announce a withdraw to other routers so that the route is not reachable to the internet. But for some reason, one routers, maybe for a bug or something other thing, will not process correctly the withdraw and will not announce the withdrawal to other routers. So there is a network that is split in two. You have some routers that have the information that the prefix P is not reachable anymore, and other routers that still have the route, and this will cause a lot of problems such as blackhauling and so on. But with xBGP, you can actually add a new plugin that will check the routing table each night, for example, and if the route is in the routing table in older than unit of time, so maybe for example 4 weeks, then you can ask to your upstream routers to confirm if the route is still valid, and if it is still valid, then the router will make the corresponding exchange of message to say, okay, so the route is still reachable or not. So this is a quite special use case because it does not directly influence the BGP workflow of BGP, but this is more related as maybe I would like to say cron job or background task. And so we have a kind of insertion point where you can execute some of these tasks for maybe for maintenance stuff and so on. Okay, so now we have a way to add programmability and innovation inside network, but one question now is, does using xBGP have an impact on router performance? And to answer this question, we have made a small experiment where we have made a left router to inject a full routing table to our xBGP routers, and we measured the conversion time of this green router. And the first thing we managed to do is to check if there is an additional overhead or not, if there is no xBGP program that are executed inside the routers. And actually, there is a small overhead because you have to initialize some data structure related to xBGP, and also to check if there is some plugin which is inside the implementation. So there is a slight overhead. And also, we have considered a worst case which is the re-implementation of route reflection. So we believe that this use case is a complex one for xBGP, and this is the worst use case you can have. And there is a quite high overhead, I would say. For FR routing, you have a conversion type of plus 13% and BERT 8%. Yeah, so the difference is explained by the data serialization between FR routing and BERT. This was more easy for xBGP to convert a data structure to vendor neutral structure that the xBGP extension can use inside the plugin. And also that the eBPF JIT compiler is not efficient as native bytecode, but this is still a prototype. There is still some improvement to be made inside the prototype of xBGP. So the last thing I would like to share is, yeah, now we have something to add a new feature inside routers, but the code that is executed and written by the operators is untrusted from the point of view of the routers. And so if I take back my geographical location extension, maybe this one has not been correctly written. There are some corner cases that I do not think during the development process. And so this could crash the routers, and this is something we do not want. Because routers are generally expected to run 24 hours out of 24. And so we managed to develop a kind of framework on top of offline verification tools, where you have to pass the source code of your extension, annotate it with a custom verification macro that we have developed. And then this source code with annotation will be passed to the offline verification tools. If all the properties are satisfied, then you can compile it to eBPF bytecode and then inject it to your router. So there are a lot of properties. So there are basic one and properties related to BGP. So the basic properties are the termination. We do not want that the plugin is stuck in an infinite loop and to completely break the router. There are also questions of memory safety. So our prototype is running on top of C code. But I agree that if you write your extension in Rust, for example, then the question does not arise. And there are also some stuff about virtual machine isolation and API restriction. So, for example, if I would like to use some part of the API of xBGP, but I'm not allowed, then there are runtime check that has made on our framework. But the most important one is the properties related to BGP. And I will also retake my example of Geolock, where when you want to add and when you want to advertise this feature and this attribute inside your routers, they must satisfy a wire format, a header. And so what you have to do is to write and annotate your source code with the corresponding value. So for example, the flag must be 8, the type code must be 2A, and so on. Also, the latitude and longitude must be valid in a valid location on the Earth. So yeah, so you have to write it yourself, and then the offline verification tools will make sure that the header is correctly formatted. So this concludes my presentation. So we believe that with xBGP, BGP implementation will become truly extensible. We have made the job for BGP, but we believe that the same methodology can be applied to other routing protocols such as ISIS or SPF. And if you are interested to know more about the internals, the use case, and other stuff that we can do with xBGP, you can check the corresponding paper. Thank you.